Hey, hello, and welcome this morning. As you can see, I am not in the picture, but I am now. So, hello and welcome to day number 12 here for summer school. And a big day because you guys just took test number 2. And I hope it went well for you. And I've got a bunch of announcements here to make for you, starting with the whole reason I wasn't in the camera frame to begin with is I had to start the camera on my own, and we've got a narrow window here today. I'm on my own here today, and so my camera person Ron, you've heard me refer to a couple times, is unable to be here today, and so I'm kind of on my own. I've been practicing with just kind of this little window, this one board and the equipment and some tables I can swap in and out. And so I think this is going to work well. We'll have to wait and see, and I'll play it back here. But I suppose on the good side is it turned out to be a good day for this to happen, because we don't have 2 lectures today. And so you just got done with the test. If this was face-to-face, we would have just said, okay, take your 20-minute break to kind of clear your head, and then let's come back here and start the lecture. And so this is the one and only lecture for day number 12 here. And so this is June 15th. And like I said, you just took an exam. That being said here, you also have a lab today, at least officially in lab. Let me hold up the syllabus. Without a cameraman today, I know he can't zoom in, but I think this might be reasonably clear. You can look at your syllabus, but just to give us a heads up as we're coming to the end here, we're right here on the schedule. We're at June 15th. There it is, test number 2. That's what you just took. Chapters 7, 8, 11, 12, and 13. And so you've taken those. And so now, let me just double check. I want to make sure the sound's on. Okay, I think it is. I can't really do a sound check here, but or a really good video check until... well, I play it back. So I'm just going to keep going for an hour and a half, and then I'll play it back. And I guess if I got to do it a second time, we'll end up doing it a second time. But here is the schedule. As you know, we're a little behind, and so we're going to start here 15 and see how far we get into 15. 15 is not a real long chapter, so I think we'll get pretty far. I doubt if we'll finish it, but we'll keep our fingers crossed here. And so that's the plan for today. But I wanted to also look forward here, because believe it or not, we're coming to the end. Really, we only have 1 more week and 2 days, and you're done with this summer school 1. And you might be done with summer school. Depends if you're signing up for summer school 2 or not. But we just have then, now that you've done test number 2, we're just going to keep going as far as we can to get to test number 3, which is next Tuesday. So that's only 8 days away. And then the following day on Wednesday is your final exam. And so that's the end. So 1 week, 2 days, that's, I guess, 9 days. And we're done. So this is all going to go pretty quick. A lot to do next week. And I wanted to emphasize, and I hopefully will remind myself to keep telling you every single day that we come this week, that use the long weekend. Use this Thursday, Friday, Saturday, and Sunday. Whatever it takes to free up your schedule. If you're, like I said, fortunate enough to still be working, that's great. But if there's any chance you could swap shifts with somebody, I think it would do you well to have this weekend as free as possible and to work ahead. Because tomorrow, Tuesday, we're going to have our 2 lectures. Wednesday, we'll have our 2 lectures. We'll come back on Monday, have 2 lectures, and then boom, Tuesday, you have a test on that material. And so it's not like the other tests where you've had the weekend before to get ready. You've got material coming at you on Monday, and then boom, it hits you on Tuesday. And then after Tuesday, you have a 1 lecture, and then boom, it hits you with a comprehensive final exam. So I would encourage you this weekend to not only start preparing, so however far we get to on Wednesday, you spend this weekend learning that material plus reviewing all the way back to the beginning. Because what that means then is when you hit on Monday, Monday, you have new material. You can learn it on Monday, then you can digest it, and since you've already learned all the stuff that we're doing this week, Monday, Tuesday, and Wednesday over the weekend, then that'll put you in a good spot for the test number 3 on Tuesday. And then you'll leave in more material on Tuesday afternoon, one lecture, and then you can then do that Tuesday night, learn it. And so you'll be in a good position to be ready for a comprehensive final exam on Wednesday. I guess a better way of saying the same thing is this weekend, if you spend the time learning and relearning all the material for these 5 weeks, that's what you should really do this weekend. That way, this next week, Monday, Tuesday, Wednesday, that'll come pretty quickly, where you'll have new material and a test and, of course, some labs to do. You'll be in a good position to just have enough time to do that. Plus, you already spent the time over the Thursday, Friday, Saturday, Sunday, over the weekend. And that's the best way I can give you or suggest to you to prepare for test number 3 and the final exam. So I'll keep saying that as the week goes along, but we're really coming down to the end here. I'll flip the page here and go to the labs. As you know, we've been working through the labs. We're a little bit off the schedule of the labs. We're one lab behind because, as you remember, we did not do a lab on the day of test number 1. I thought it would be worth your time and effort, and I'm glad I did, to do a review of the test. Because again, not being face-to-face, I know a lot of you have a bunch of questions, so I made that little video where I just took the camera and pointed it straight down on my desk and I worked it out. And I'm going to do that same thing here. As soon as we're done here, I'm going to go back to my desk, I'm going to take that camera, I'm going to put it up on a mount, and I'm going to shine it down here, and I'm going to start working away. And I'll just go right through that exam, and that'll be your lab for today. So we're not going to have the lab that would be scheduled, which is the pendulum. We'll do that tomorrow. There's a couple reasons. Like I said, number one, I really think that worked out really well. And so I'm learning to do things a little bit different in this environment of remote learning. And like I said, the feedback I got from you students was that was helpful. And I really felt it was more helpful than a lab itself. And so that's why I did it. And that's why I'm going to do it again. And so you can even give me more feedback, because I'll probably do that for the 3rd one too, unless you guys protest and have something different there. But I really like the way that worked out. Test 3 also is perfect, because if I do that, then you can be getting ready for test 3, or you can see the answers and the review of test 3 that evening, Tuesday evening, before the final exam on Wednesday. That's next week. So, like I said, I like that. And that's really kind of the main reason, but the other, of course, 2 other reasons, and I'll just throw them out there. One is I don't have help today. I don't have a Ron, so that makes it a little bit harder to get the lab set up, and he knows where the equipment is, and he sets that all up, and the video camera in the back of the room. And so I'm missing him for that. But also a big one, you wouldn't know this, but I'm getting a lot of emails from our chancellor and our my deans and VPs saying, give this some thought. We're in a new environment. What kind of things can you change from your normal process that would still keep the education level and rigor high, and keep the bar high, but might make things a little bit simpler for the students, given this events that are going on in the world. And so I gave that some thought, and I go, you know what, this would be good. Even if we drop a couple of the labs, in this case drop 3 of the labs. I checked with the counselor, and they said that would be fine. We don't have to do 15. We can drop it down to 12. And so that would fit within the state guidelines of education. And then supplementing that with a review of the tests, I think would be really good. So it's nothing you have to really turn in. It's something you might even say it's more optional, but I would encourage you all to do that, because I think just seeing me work through them might give you some clue into some problems, especially the ones you got wrong, of course. Now, if you got it all right, maybe that's not as much as a help, but it might be nice to see the logic in a different way and to see me think. And so that's the kind of thing that I'm glad I'm putting it on those videos, because again, it's seeing somebody think is where the training comes in, and I think that works best face to face, and we don't have that this summer. And of course, summer school is already a fast pace, and so given the remote learning and the fast summer school, that's the long answer to then. We're not going to be doing the formal lab on the pendulum today. We're going to learn about the pendulum here. I've got a pendulum and some other equipment here to show you. That's what chapter 15 is on. Oh, one more then quick announcement here. Here's where we go. We're going to start chapter 15 here in a second. And chapter 15 brings us into a new area of physics. As I said, the main part of this class was really the chapters 1 through 8 to get you well acquainted with mechanics so that you will be successful at the next level in Physics 121. And then the last 3 chapters have been on the structure of matter, and you can see how big that was. In other words, how many different principles of physics are buried in the fact that the atoms jiggle around. And now we're about to enter a phase of 2 chapters. You might even say 4 chapters. I'll say 2 though, because we get into vibrations and waves, really mechanical waves. And so for the next 2 lectures, the next 2 chapters, maybe it's 3 lectures, but the next 2 chapters, this 15 and 16, are on waves, mechanical waves in particular. And then 17 and 18 kind of continue on with waves, but they do get away from mechanical waves. They get into electromagnetic waves, and we get into light and optics and radiation, and so some neat stuff coming up to us in terms of our physics. All right, well, I better get started here, and let me go ahead and grab my piece of paper and kind of remind myself as I looked at the video camera. I noticed then that I tried to zoom in then on this whiteboard here, and tried to get a good depth of focus also. So I think the autofocus will also, I think, help if I move forward in front of this table or back here. But let me get started here. Chapter 15, as I just said, is a new section. It's entitled here Vibrations and Waves. And so that's where we will begin. And it's a little generalized. That's kind of the good and the bad at this chapter. You'll see here that the author tries to be general about waves and vibrations and tries to stay away from specific examples. That can be useful, but I think it's better to see some examples. So I brought out a pendulum and a horizontal oscillator and a vertical oscillator, and so I'll play with those for specific examples of oscillations, because I think it helps to see them, but I'll also emphasize, hopefully you'll see the bigger picture. I guess I would describe it a little bit like learning algebra, where x is this variable, and a lot of times students, especially non-science and technically oriented students, will look at an algebra equation and go, in frustration usually, why do I want to solve for x? I can't solve for x. Why do I care about x? You don't have to do that in the real world. Nobody wants me to solve for x in the real world. And they're missing something big when they say that. They're missing that x is not just the letter x, and that the algebra class is trying to be abstract and trying to get you to realize that this x could stand for anything. This could stand for the payment on a new car. This could stand for a loan payment to, for your school loans and how to get there. It could stand for how much would it cost for a down payment on that car or that phone, or how much the apartment would cost. There's so many things that you might want to compare an old car that keeps breaking down to a new car, to a used car, new tires versus old tires, how much I work now versus how much do I borrow now in order to get done with my degree, to have a job that pays even better. And so you can set all that up in an algebraic equation. Is it worth for me to go to school part-time and take 6 years, or is it better for me to finish up in 5 years or 4 years and then get this higher paying job now that I have my bachelor's degree? And if you sit down and write that in in algebra, you will see right away, I do care about x, and I know what x is. X is an important decision in my life. It'll make a difference in my life income and the quality of life I live from here forward. And so I can't overemphasize the power of algebra, and I don't get how anybody can live without algebra and solving it, but people do, and they don't get it. And I guess what I'm saying is the algebra is gone too far in the sense that in trying to be abstract, you run the risk of students not seeing how it applies to everything. And so that's the same thing here you'll see in this chapter, that he tries to be very abstract with the waves in general. He just says the waves, and he doesn't say are they water waves, are they sound waves, are they light waves. He doesn't specify which they are. And he's trying to get you to realize that by being abstract, they apply to all the waves. Of course, the danger of that is sometimes students will see how it applies to nothing if we're too abstract, like in an algebra class can be. So I will try to point out that there is an importantness in being abstract, but too abstract also, people don't see the value in it. So I'll try to balance that. And here's where he starts off being abstract. He gives it just a bunch of words, a bunch of definitions. He says, what is a vibration? Sometimes he uses the word oscillation. And so I'll just put both here and saying, okay, whether I use the word vibration, something's vibrating, or something is oscillating, it's that same idea. And kind of a simple layman's definition is to say it is just kind of a back and forth motion. Maybe a little fancier is to say it's a periodic motion. It goes back and forth. And that's why I said over a couple of these. Let's see if I can move around to the front of the table, and I'm hoping the autofocus grabs me here. But if I take this pendulum and I pull it to one side and swing it, it goes back and forth. If I put a little bit of mass on the end of this vertical spring, and I think I better stand on this side, or, well, I mean, who cares if I'm in the picture. But if I pull this down and let it go, it goes up and down. This horizontal oscillator, if I put one of these masses on here and pull it to the side and let it go, it again goes back and forth. And so that's what is meant here by an oscillation, this back and forth motion. And so nothing fancy. I would just say, yeah, these things all oscillate. And I would even go further to say all of these things have a lot of the same properties. Even this one here that you'll see later on, it oscillates here. Well, another good word to get us started is what your author calls the equilibrium position. Maybe another way of saying the same thing is to say it's balanced position. And so all these things that oscillate, they oscillate because if they get off of their balance position, their equilibrium position, the forces involved try to send it back. And so in this horizontal one here, if I pull it to my left, your right, and let it go, the springs on here want to push it back. Now, it pushes it back, gives it some momentum, so when it gets back to this balance point where the forces are equal, it just blows right past it. And as it goes to the other side, which would be my right, your left, then the forces push it back. And so it just is constantly fighting to get back to equilibrium. And so there's this forces going back towards the balance point. That's why we call it the balance point, the equilibrium, because the forces are going like this. And then, of course, the momentum carries it back and forth. And you can see that here with this vertical one, right? This right here would be its balance point. This would be its equilibrium. This is where gravity pulling it down and the spring pulling it up are balanced. And if I pull it down, well, the spring now pulls a little bit more than gravity and shoots it on up. And if it shoots it up past equilibrium, then gravity is more than the force from the spring, and so it goes back down. Gravity and the stiffness in this case would make a balance point of straight up. The pendulum here, again, gravity is it, and the tension in the string, and so its balance point, its equilibrium point is just kind of, straight down, right in the middle. And so all of our things that oscillate have that property of some equilibrium point, some balance point. Now, another 3 words of definitions here is called the period, the frequency, and the amplitude. And these two, the period and frequency, oftentimes for the beginning student get mixed up. So let me see if I can get those clear. I think the easiest one is the period. It just simply says the period is the time required for one, and I'm going to go ahead and put cycle to match your author, but I could also use that word over there to say, hey, it's one oscillation. And so notice it says time. And so it is a measurement of time. And so the units here will be units of seconds. In fact, we will go ahead then and use the symbol capital T and the unit of seconds then to measure the period. How much time does it take? So this one here, if I were to make it go back and forth, maybe that's a little fast for me to count. Maybe I'll come to this one here. Man, I like that one better. Maybe I'll pick this side right here and say, okay, how much time does it take to get back over here? And so if I got here and I started with 1,000, 2, 1. It wasn't quite 2 seconds. Maybe I'll call that 1.5 seconds. And so I would say the time, the period is 1.5 seconds. This one, as you can see, is something maybe a little less than that. So if I get over here to this edge, I'll go ready, start, 1. Okay, not even 1 second. This one here, kind of the same idea. If it gets down to the bottom and I go ready, 1,000, almost about 1 second before it came back down to the bottom. Let me emphasize, it doesn't have to be the bottom here. I can see how long does it take to get to the top. Just like over here on this pendulum. It doesn't have to be over here on my left. I could have started it on the right. I could have started it in the middle. Now in the middle I'd have to be a little careful because I would have to go, say, start it at the middle moving left because it will go back to middle but moving right. So that's not a full cycle. And then it'll go up the other side and then come back and go on left again. So from middle moving left to middle moving left would be 1 cycle, would be 1 oscillation. And the time it takes for that is 1 period. So you can see we're going to use the capital T for that because, you know, the lowercase t was the general answer of what is time. But the frequency, as I was saying, often gets confused with the period. Let me define the frequency then as the number of cycles or oscillations. The number of cycles per second. And so it's a rate. And I think because it has per seconds in it, which is a measurement of time, students confuse period and frequency. And they almost have the same words in them, and I think that's why they get confused. So let me spend a moment here to try to point out these are not the same, although they are related. The symbol I'll go ahead and use is then the F for frequency. And you begin to see the difference between period when you say, okay, what would the units be? It would be a number per second. And so if I take something that maybe goes back and forth many times, I'll take this weight off and do this. And that looks like roughly to me back and forth 3 times in 1 second. And so I would say its frequency is 3. It has 3 cycles in 1 second, or 3 cycles per second. So the unit here would be cycles per second. And that is given the name Hertz in honor of one of the great scientists working in the field here. And so the unit for frequency is the Hertz. And like I said, you might get these confused here. In fact, maybe you'll see it better if I kind of explain the math. Let's see, I'm learning this myself, so I got to stay here. I was tempted to walk down to that part of the whiteboard. And let me just kind of clear this off here. But this is saying here that the period and the frequency are closely tied together, but they're not quite the same thing. They're the reciprocals of each other. I hope you see that in the name. This is the time for one cycle. And so if I come back over here, the time for one cycle is 1/3 of a second. It only takes 1/3 of a second to make one cycle. So the period is 1/3 of a second. But its frequency is how many times did it make a cycle in 1 second. Exactly. So if the frequency would be 3, whereas the period would be 1/3. And so you can even see that in the units. You take the reciprocal of cycles per second, you get then seconds per cycle. Exactly. The seconds, how many seconds per cycle is the period. So I'll put a box around this, and you can, write it as either way. I don't suggest you do both, but this is a way of me trying to point out, don't confuse period and frequency. They use the same words, but they are the reciprocal of each other. And because they use the same words, they often get confused to the student. And then you got to listen carefully and read carefully when it comes to a test or a homework and say, oh, wait. Are they talking about the frequency, or are they talking about the period? You see, I think one of your homework problems sounds something like this. You've got a captain on a ship and the waves go by. And the captain of the ship says, yeah, my boat went up and down in about 10 seconds. Okay. So the captain just gave you the time for one oscillation. That's a period. So the period is 10 seconds. But the captain could have also said, yeah, I was sitting here and I went up and down 6 times in a minute. Well, that's kind of a frequency. It's not a frequency in per seconds, but it would be this, I'll put it here, it would be 6 cycles, there it is, in a period of time, which would be 1 minute. But if then you replace 1 minute with 60 seconds, you would then have 1/10 of a cycle per second. And that's the frequency. And then, of course, the reciprocal of 1/10 of a cycle per second would be its period, which would be 10. So you got to listen carefully to the problem in order to straighten it out. Is it a period or is it a frequency that is being given and discussed here? And then, of course, if I need the other one, I can take the reciprocal, because once you know one, you know the other. All right. So be careful with those. Now, the amplitude needs probably a little clarification too. The amplitude is defined this way. It is the maximum displacement from equilibrium and I'll just put from its equilibrium position. But let me pause right here, because maybe I'll use this pendulum here. If this is its equilibrium position, and I pull it to the left 10 centimeters and let it go, it will swing 10 centimeters back to equilibrium, and then it'll go another 10 centimeters over to my right, then it'll go another 10 centimeters back to equilibrium, and another 10 centimeters to complete one cycle. The amplitude is 10 centimeters, not 20, not 40. The 20 gets confused because if you were measuring from the far left to the far right, you would get a 20. But that's not the amplitude. That's two amplitudes. The amplitude is how far from equilibrium. And so I'll say it again. The amplitude, you pull it over 10 centimeters and let it go. That's 10 centimeters from equilibrium. That's the amplitude. Even though from the farthest to the left and the farthest to the right is 20. And even though the full distance it travels is 40 in one cycle. It's not 40, it's not 20, it's 10. That's the amplitude. The same thing here with this vertical one. I could start it here and pull it down 10 and let it go. But if I were to measure from its lowest spot to its highest point, I would get 20. And students do that, sadly. Even in the description of a problem, there'll be a problem that describes saying blah, 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 and the lowest point was, and the highest point was, and then you could subtract the two to say, oh, that difference is 20, and students carelessly want to call the amplitude 20. And so this is my warning for you. That's not the amplitude. That is twice the amplitude. Another good example is water waves. If you like to go into the ocean, a lot of times, the waves are about 4 feet. And then your first reaction is, well, 4 feet, that's not very tall. I'm a short person, and I'm 5'8", and other people are a lot taller than me, and 4 feet, boy, that sounds like the waves are only this big. That doesn't sound too intimidating. But you got to remember, and maybe a picture is worth drawing. Here's of course, the bottom of the ocean. Maybe here is the surface level without any waves. And so when you stand in the water, let's say, maybe you're already 4 feet deep right there. So 4 feet is already way above your head, but that's not what you would see anyways, because what you would see is the wave going up and then the wave going down. And so as it comes to you, you would see the whole face of the wave. And so that means it's 4 feet down and 4 feet up. From high to low is 8 feet. So when you give an amplitude of only 4 feet, it's actually the face of that wave is big. And so that's a big wave. And there's a huge difference between me thinking, oh, the waves are only right here, to, okay, I'm here, and I'm really at the bottom of that wave because the top of that wave is still 7 feet above me. That's a big difference here. And so I'm trying to use that as an illustration of be careful with the definition of amplitude. And it's not the total distance it travels in one cycle. It is not the distance from one max to the other max. It is from equilibrium to the max. Now we'll need a symbol for this, and so a good choice is capital A for amplitude. And the units, of course, it's a distance, so there'll be meters or centimeters or whatever is an appropriate prefix in front of meter to represent its amplitude. All right, well, like I said, your author starts off here with a bunch of definitions, and those are the definitions that he starts with. Let me go ahead then and clear off a little space on our one little whiteboard we have today. I'll leave that formula up there with the reciprocal between period and frequency, because your author has a quick discussion about a couple of things that oscillate, and he starts over here with spring, and so that's where I'll begin. And he says this. He says the period, that is the time it takes for one cycle. So I'll put here capital T for period. When you have a mass on a spring, and so I should emphasize, I'm going to give you a formula here, but it would only be good for a spring. And so it would work for this thing. I'd call this a spring. It's laid out horizontally. I'd call this a spring. It's laid out vertically. But it is not appropriate for this. This is a pendulum. Well, let's talk about that one after we talk about the mass on a spring. But he says the time it takes is equal to, and he gives this formula. He doesn't derive it. And of course, he doesn't derive it because it does involve some calculus. And so I'm going to say the same thing that I said way back when we did our centripetal acceleration. That let me give you the formula. Let's work with the formula. It's a good first step in our Physics 102, our introduction to physics. And let me promise you then that I or whomever is teaching the class will work this out. I believe this is done in chapter 15, and so that would be Physics 123, and that's what I teach, so I'm sure I will be doing it. And so there is some fun calculus in this, and so I look forward to that day of fulfilling this promise. But I will work this out, okay? And so that is the period it takes. Now, let me give some symbols here. The symbol for mass you've seen before as m, and so I'll just leave that. But the spring constant is worth mentioning. The symbol we like to use for this spring constant is K. And for this to make any sense, I got to get you to understand this spring constant a little bit. Well, let me come over here to this vertical spring, and I think you can kind of get a feel here for what's going on here. Maybe I'll start with some mass here. I'm hoping on the video here you could tell that the one I have on here now is smaller than the one I'm about to hook up. This is 100 grams. This is twice that at 200 grams. But if I pull it now, I'm hoping you can see, and I don't know if it's better for me to stand on this side or that side, but I'm hoping you can see that is taking a longer time. In other words, its period is bigger. It takes more time to complete one cycle. Maybe I'll really show it by putting yet another 200